In this example, we would like to find dy dx in the case where 4x squared plus 9y squared is equal to 36. This curve is an ellipse, which means it looks like an oval. If y is 0, then x squared has to be 9, because 4 times 9 is 36. So this is 3, and this is minus 3 here. And if x is 0, then y squared has to be 4, because 9 times 4 is 36. So this is 2, and this is minus 2, and we have an oval looking shape known as an ellipse. So I think I drew this 2 a little too high there, so that 2 should be down here. Let's ignore that. Okay, so that's what it looks like, and by finding the derivative, we will be able then to take any point on our ellipse and say what the slope of the tangent line is. The slope of the tangent line comes from the derivative dy dx. Okay, so this curve is not a function of x because it does not pass the vertical line test. So y is not a function of x. However, we will assume for the purpose of the computation that y is a function of x. And even though that's not true for the entire ellipse, it is true near a point on the ellipse. So if I take this point here on the ellipse, then just this little section of the curve around that point is the graph of a function, and that's all that's really needed in order to find the slope of the tangent line. So it's reasonable then, when we're finding the slope of a tangent line, to assume that y is a function of x. Okay, now to find dy dx, the method is called implicit differentiation, and the key is to take the derivative with respect to x of both sides of the equation. So the left side is 4x squared plus 9y squared. We're going to take the derivative of that, and on the other side we want the derivative of the constant 36. That side's very easy. The derivative of a constant is 0, but we'll get to that in a moment. The derivative of 4x squared, that's an ordinary derivative. The answer is 8x, plus the derivative of 9y squared. That is not an ordinary derivative, so I'm going to wait on that for just a second. The derivative of 9y squared. And on the other side of the equation, the derivative of 36 is 0. Okay, so what is the derivative of 9y squared? We have our 8x, let's copy that down, plus the derivative of 9y squared. We are thinking of y as being a function of x, so therefore y squared is a composition where y is inside and the 2 is outside. The 9 here in the front is just a constant multiple. So we're going to use the constant multiple rule to take the derivative there. So according to the constant multiple rule, we just have 9 times the derivative of y squared. And again, y squared is a composition. Y is the inside, the square is the outside. To take the derivative of a composition, we use the chain rule. So the derivative of the outside is 2y, and then the derivative of the inside is y prime, or I'm going to use the symbol dy over dx for the derivative of y with respect to x. And then we have equals 0. So we have 8x plus 18, 9 times 2 is 18, y times dy dx is equal to 0. We want to solve this equation for the symbol dy dx, and that'll be the answer. So to do that, I'll move the 8x to the right side. So 18y times dy dx is equal to negative 8x, and then divide by the 18y. So dy dx is equal to negative 8x divided by 18y, and that simplifies to negative 4x over 9y. So that's the answer. The slope of the ellipse is at a point xy is given by negative 4x over 9y.